In this lesson, we will review linear equations. The goals of this lesson are to graph a linear equation, to determine the slope and y-intercept of a line graphically, to write the equation of a line, to find x and y intercepts from the equation of a line, and to determine if a point represents a solution. So we're going to start out with some vocabulary here. We first of all want to talk about an x-intercept. Now, an x-intercept is the coordinate of a point where the line intersects the x-axis. So we first of all want to talk about what the x-axis is. That is going to be this horizontal line on the coordinate plane, and then the y-axis is going to be the vertical line. So if we're looking for an x-intercept, it's going to be a point that falls on the x-axis, and a y-intercept is going to be a point that falls on the y-axis. Next, we look at slope, and we can think of this a few different ways. One way is to remember that it's equal to the rise over the run, and that means it's the vertical change over the horizontal change. And we want to be able to identify what type of slope it is just by looking at the words down here. So if it's a positive slope, we want to remember that from the left side of the graph to the right side of the graph, it should go up. And we're always going to read each graph from left to right, just like we would read a sentence. So a negative slope is going to go down as we move from left to right. A zero slope is going to be a horizontal line, and then an undefined slope is going to be a vertical line. And one way I always remember this is that if you think about skiing, like you could ski on this slope, we could ski on the negative slope, we could even ski on this slope right here. So all three of these are considered slopes because we could ski on them. However, when we get to this undefined slope, I think we are going to run into some problems and we would be falling off of a cliff here. So remember that when it looks like this, that is not a slope. So we can keep the skiing example in mind. Okay, next when we look at graphing the equation of a line, we want to remember the slope-intercept form of a line is y equals mx plus b, where m stands for the slope and b stands for the y-intercept. Now there's a few different steps that we want to remember when we're graphing. The first one is going to be to plot the y-intercept. So we're going to want to identify what that y-intercept, the b value is, and plot that. Then we're going to use the slope to find another point, and then finally we'll connect those points with a straight edge, making a solid line throughout the graph. So here's our first example. We start out by identifying the y-intercept and then plotting that. From there, we look at the slope. Our slope here is 3. Now we always want to kind of think of that as a fraction. The fractional equivalent to 3 would be 3 over 1. So we have to travel up 3 units and to the right 1 unit. Now you could also go down 3 units as long as then you'd go backwards 1 unit, and that would give you an appropriate line. So now we can connect those points, and you just want to kind of make sure, we know that this is a positive slope here, and so it should be a positive slope here. And we can read that left to right, and it is going up. It continues to follow that same pattern where we're going up 3 and over 1, up 3 and over 1. So we move on to example 2. Now again, we want to start by identifying what the y-intercept is and plotting that. So here we are at positive 2 on the y-axis. From there, our slope is negative 1/5. Now that negative can get associated with either the top value or the bottom value, but it's definitely not both. So we can either think of this as going down 1 and then to the right in the positive direction 5, or we could go in the positive direction 1 and then in the negative direction 5. Either way would give us an appropriate value that would fall on that line. Once again, you want to double check before we move on. This is a negative slope, so it should be traveling down as we move from left to right. So we'll try these next 2 examples. So first of all, when we look at number 3, automatically we should notice that it's very different from the other ones. It doesn't start with a y value. In fact, we can see here that there is no y-intercept at all. So now I'm thinking it's not going to even cross this y-axis. What I do know is that the value of x is equal to negative 2. Now that happens to be the x-intercept. So I can go ahead and plot that. And from here, because it's not just saying that the value is at, say, negative 2 comma 0, it's saying x equals negative 2, that tells us that it's a line, and that would be a vertical line. So again, this is kind of the unique situation where this isn't actually a slope. We say that the slope is undefined here. And the red flag should be, as soon as we see that X, that it's going to be a vertical line. And then when we move to number 4, again, we're looking for a y-intercept. Nothing is written there. So we want to think about what would be there if we were to write something. And hopefully we're saying that that would be 0. So we can go ahead and plot at 0. We see that the slope is positive here. So again, in our mind, we're kind of picturing it's got to go up as we move from left to right. And this one goes up 1 unit. It rises 1, and then it's going to go 4 in the positive direction. Once again, here we could put a negative technically with both of these. So we could also have gone down 1 as long as then we went backwards 4 units. That point would also fall on the line. We graph it and we are done. Okay, in the next slide, what we're looking at is to determine the slope and y-intercept of a given line. So here we're given this line here, and we want to find just the slope and the y-intercept. So once again, when we're looking for the slope, right away I can see that it travels up as I go from left to right. So I want to remember it's positive right away. From there, I'm going to count how many does it go up. So I want to pick 2 nice points on the line, and I'm going to count how many times does it go up. It goes up 1, 2, 3, 4. That's the rise. And then it goes over 1. So if I get 4 over 1 for this, it's going to reduce down to just positive 4. Then our B value, which is our y-intercept, that's going to fall at positive 1. And that would be the answer to number 1. For number 2, first thing we want to look at is what type of slope. Again, this one is showing a negative slope. So as soon as we see that that's negative, we need to put in the negative value so we don't forget. Now from here, again, I want to identify 2 nice points. I started here. That goes down 1 unit, and it's going to go over 1, 2, 3, 4, 5 units. So my vertical change was 1, my horizontal change is 5, and that's going to give me a slope of negative 1/5. And then finally for B, we're looking at the y-intercept there. That y-intercept is at negative 4. Okay, we look at number 3. With this one, again, for the slope, we see right away it's going up from left to right, just like we would read a sentence, and that's going to tell us it's a positive slope. From there, we're going to identify 2 nice points. This looks like it goes up 1 to go over 1. So 1 over 1 will reduce to just 1. And, you want to make sure that it continues to kind of follow that pattern, and it does look like it's going up 1 and over 1 throughout the graph. And then for our value for B, that's going to be our y-intercept. We can see that it's down here in the negative region. It falls at negative 7. So we have our 2 values we're looking for. Now right away with number 4, noticing that it's a horizontal line, hopefully we can identify and remember that that's a 0 slope. So I'm going to fill in that our value for M is 0 here. I didn't really need these 2 points here, but I do want to talk about it a little bit. We're not going up. So if I was going to try to count how many am I going up to go over, well, I'm going up 0, but then I'm going over 1, 2. This point isn't in a great spot, but it looks like it's about 0 over 2. Well, if that's the case, 0 divided by 2 would reduce to 0 anyway. Then finally, our B value is at positive 2, and that would be the answer to number 4. So now we're going to do the same thing, except for we have to fill in the entire equation. So here in number 1, we see right away it's a positive slope. We also want to identify 2 nice points. So I start here. That's going to be my y-intercept, which we'll talk about in a minute. And then here's my second nice point. And when I say nice point, I'm meaning that they're crossing at the intersection between 2 grid lines. So I'm not going to pick a value that would give me a decimal or a fraction. So if I'm counting between these points, the rise is 1, 2, 3. The horizontal change is going to be 2. So if I've got 3 over 2, that's my slope. From there, my y-intercept is going to be here at negative 2. So I end up getting y equals 3/2 x minus 2. And then for number 2, we see here that we have a 0 slope. If I find 2 nice points here, again, I don't have to do this, but I see that it goes up 0 to go over 2 units. 0 over 2 would still reduce to 0. And then my y-intercept here is at 3. So when we go to write this, we're going to just get y equals 3. Now you could write y equals 0x plus 3, but the 0x would cancel out, so that is unnecessary. Okay, when we get to this example here, we see right away that this is a little different. We don't have a y-intercept here, and as far as the slope is going to be undefined. Once again, we can use 2 nice points to kind of think about the fact that if I was going to try to move from one point to the other here, there is a vertical change. I would say it goes down 1, 2, 3, but then it goes over none. So if I had -3 divided by 0, that is an invalid division problem. We cannot divide by 0. So again, that's going to result in an undefined slope. Our x-intercept here is going to be at -5. So we do end up just getting x equals -5 for that line. Again, you have to put the x equals, otherwise it doesn't represent a line. And then finally for number 4, this one, when we look at the slope, we see right away it's negative because it's moving down from left to right. We want to identify 2 nice points. We can count that it goes down 1 and it goes over 1, 2, 3, 4 units. So that is going to be -1/4 for the slope. And then also we have a y-intercept that is up here at 1, 2, 3, 4, 5, 6. So our equation becomes y equals -1/4 x plus 6.